Hi, now that you've learned about muscle contraction, we need to talk about where does all that ATP come from to allow these contractions to occur because they're happening all the time. So we're going to be coming back to ATP production, some things from Bio 119 like glycolysis and aerobic cellular respiration. So we know that contraction uses a lot of ATP, but we also know that muscles store energy at least to start a contraction and get us through the first few seconds of an activity. Then they can actually make more ATP as needed. And again, the way you make it is through glycolysis and aerobic respiration. However, we know that muscle has an immediate supply of energy in the muscle, and there's two molecules that do this. First, we have ATP, which I know you're familiar with, and ATP is your immediate energy source. We know that with this enzyme ATPase, it breaks ATP down into ADP and phosphate, and that releases a lot of energy. And that energy is what allows that myosin club head to cock, and you do the power stroke, and then it detaches, and so all that energy is critical. We have roughly 5 to 6 seconds of ATP stored inside our muscles for right now. And then there's another high energy compound called creatine phosphate, or CP. And creatine phosphate also could be broken down into ATP and creatine, which we eliminate. It's a waste product. And that gives us roughly 15 seconds worth of energy. So the very fastest is our ATP and our CP processes. So this is roughly, maybe depending on what book you look at, 10 to 20 seconds max of energy available in your muscle. Once you're past that point, you're going to have to make ATP or you're done. So if you think about it, why is it good that we have this built-in 10 to 15, 10 to 20 seconds worth of ATP in our muscles? Can you think of a reason why that might be helpful? Well, think about your fight or flight response. So when danger occurs and you have to either fight or flee, this is basically giving you a good 10 to 20 seconds to do that process. So it's a survival mechanism. It's in there for immediate energy source. Because imagine, if it took 45 seconds to get ATP from glycolysis and you would just sit there and wait 45 seconds before you could do anything. So it's an immediate energy source. So if you're an Olympic sprinter, depending on your race, if you're doing the 100, you're using up your ATP CP, right? So because those events are so short-lived, but this is our immediate energy source, is our CP and our ATP. So again, it's stored in the muscle, it's rapid, it's ready to be used. Okay, so most of us do things that require more than 20 seconds worth of effort. So we have two ways of making more ATP. Glycolysis is the fast way. Glycolysis is if you're sprinting or powerlifting or you're doing intense activity. You will know because your heart rate will be up really high. You won't be able to talk while you do it because the intensity is so high. When we're working at a really high intensity, we can't keep up with the oxygen supply to our muscles. So what happens is there's a decrease in our ability to get oxygen to our muscle. And so our muscles are going to do glycolysis, which is called anaerobic because you're not getting the oxygen met. So luckily our muscles, when they're working at such high and fast muscle contraction, can do this. So this happens out in the cytoplasm of the cell. And the thing with glycolysis, it can only use glucose or even glycogen. Now remember, glycogen is the storage form of glucose. So glycogen has to get broken down into glucose, and then glucose can go through glycolysis and make all that ATP. So it's important that we store enough glycogen in our muscles, and so this is called carbohydrate loading. A lot of times you'll, taper off the activity and you'll increase your pasta and your carbs because you really want to fill up your glycogen supply so that if you are doing any kind of intense physical activity, you don't run out of your nutrient supply because glycolysis can only burn glucose. Now, when it burns glucose, it's not super efficient. We can't do this for very long. We only get 2 ATP back for each glucose. That's not a lot of energy. if you're curious, like, well, how much energy is an ATP? Roughly, an ATP molecule powers up 7 kcal, so just 7 calories. That's not very much at all. So we have to constantly generate ATP. Now, when we undergo glycolysis, it takes glucose and it runs it through and converts it into something called pyruvic acid. Now, pyruvic acid will normally go on to the mitochondria to undergo aerobic respiration. Okay, well, what happens when we get into anaerobic is if we don't have the oxygen available, pyruvic acid cannot go to the mitochondria. So what happens is it has to be converted into lactic acid or lactate, and then that goes out into your bloodstream. So when you're exercising and you feel that burning sensation in your muscles, that's your lactate levels accumulating because you're working anaerobically. Now, that's not what makes you sore 2 days later, but the lactate actually goes out into your blood and then it goes to your liver, and your liver actually converts lactate back to glucose. It has a little cycle it can do that, and other organs use it as energy. Your heart can use it as energy. So glycolysis is our fast way of generating energy. This is what happens during high intensity performance. You're using this process anytime you're working maybe 80% or higher of your max heart rate. So we can use heart rate to get a sense of if we're working aerobically or anaerobically. So you've probably heard of your max heart rate before. If you take the number 220 and you subtract your age, that's your max heart rate. And then you can just take a percent of that and get an idea if you're working anaerobically or aerobically. So the higher your heart rate, the more anaerobically you're working. Now, aerobic respiration is pretty much anytime you're below 80% of your max heart rate, like right now watching this lecture, you're doing aerobic work. In fact, we mostly do aerobic work. We can only do anaerobic work for a very short period of time before that lactate accumulates and causes discomfort and makes us stop. Aerobic is what we're doing right now. We do it all the time. It's called aerobic because you have to have oxygen from your blood. You might remember that hemoglobin, HB is how we abbreviate it, but hemoglobin is a molecule that transports oxygen in your blood. And then what it does is it drops it off at your muscle, and myoglobin is, and these are red pigments, by the way. Myoglobin has a reddish color. That's going to pick up that oxygen from your blood and get it inside the cell. So these processes use glycolysis. It uses something called the citric acid cycle and something called oxidative phosphorylation. So it's many, many steps. That's why it takes longer to generate ATP. It uses that pyruvic acid from glycolysis. This is why we have the mitochondria. This is how we generate most of our ATP. In fact, if this process stops, then we will die because we cannot generate enough ATP to live if we don't have aerobic work. It can also burn anything for energy. It can use glucose, glycerol, amino acids, so it can burn anything for fuel, which is great. This is where you burn your fat when you work aerobically. So you might remember these pathways from Bio 119. Very basically, you've got your glycolysis, which always happens first. And in this case, if we have oxygen available, that pyruvate or pyruvic acid can enter the mitochondria, and it goes through the steps. We're not going through all the steps again, but basically there's a transition, a citric acid, and then it does that oxidative phosphorylation. You might remember that had that electron transport chain that kind of shimmies the electrons through, and then it does something called chemiosmosis, which means it uses hydrogens to generate ATP. So this is all aerobic respiration. Now, when this happens, the purpose of this is to take hydrogens off of our food. So we strip hydrogen through these processes, and then the chemiosmosis uses that hydrogen basically to make a battery in your cell and make ATP. This process also produces carbon dioxide, which we have to get rid of. So we have a respiratory system so we can breathe in oxygen and get rid of all that CO2. So here's a summary of the main sources of ATP production. We have our immediate source of ATP and CP, roughly, we'll just say 10 to 20 seconds. Once we burn through that, if we're working at a high rate, we need to use glycolysis. So sprinting activities, powerlifting, anything that your heart rate is up high. But this can't get us very long. If you're trained, maybe 2 minutes, but maybe 1 to 2 minutes, and then that lactate starts to accumulate. Whereas what we do all all the time is the aerobic work. This is what gets us through our days and walking and jogging and activities. It takes longer, but it gives us the most ATP. In fact, it gives us about 36 ATP molecules versus the 2 we get from glycolysis. So I'm just going to touch on something really quick if you're into exercise physiology. Knowing for as far as how exercise work, there is something called OBLA or AT. So OBLA, it's in your notes, stands for, well, it's right here, onset blood lactate accumulation, and AT stands for anaerobic threshold. So this is the point that you cross over when you're exercising anytime you switch over from aerobic to anaerobic, because theoretically we can do aerobic forever, right? You'll get tired after a while, but you could walk a lot longer than you can sprint. And so once we start to do high intensity exercise, we switch over and we can't get oxygen to our muscles fast enough. We actually don't have enough oxygen for them. So now we start producing all that lactate. And then that lactate is what causes the burning pain. And then eventually it causes muscle fatigue. And then you have to stop the activity. And there's different ways. This is like ratings of perceived exertion. And you can kind of see that you can tie it in with your heart rate pretty well. So, anytime you're like 50 to 60% of your max heart rate, and it depends on how trained you are, maybe up to 70 or 80%, you're working aerobically. But once you start to cross over and your heart rate goes up, you'll notice it's harder to breathe, harder to talk. In fact, one way to know if you're working anaerobically is called the talk test. You can't talk. It's very difficult to talk because you're working so hard. So once we get into this red area, we're switching over and we're generating ATP through anaerobic mechanisms, and we're making all that lactate. And what's going to happen is you're going to have to stop the activity pretty quick. Now, if you train by doing sprints. They're not fun, right? Running all those ladders and sprints. But what it does is it actually trains the enzymes in your muscles so that you don't hit this OBLA as early. So what you're seeing here is VO2 max is kind of like your aerobic ability. So someone who's untrained is going to hit this OBLA pretty quick, meaning they're going to maybe, let's use running. Maybe they're running at a, they're doing a 11-minute mile. And when they're doing an 11-minute mile, that's the high intensity for them. And they're going into OBLA, so they're going to stop running. But if you sprint and get better, you might not hit OBLA until you're at a, let's say you're really, really fast, a 6-minute mile pace, right? So that means is you can run all the way up this fast and you're fine. You can keep maintaining that pace because you don't flip over. You haven't converted over into when that lactate starts to accumulate, which is going to make you stop the activity. And then this is just kind of an overview slide because I do think it's important to get an idea of how we use energy. So at rest, your muscles mainly metabolizing fat. So just, hanging out, walking, resting, you're burning fat. We're primarily made to burn fat through aerobic respiration. During light activity, again, less than 70% of your max heart rate, you're going to be working aerobic. So this is our long-term energy source. Once you switch over and you start to increase the intensity, so maybe you're running and you can think about the different events, maybe like a 1500 or a 400. So once we start going into faster speeds of shorter durations, then we're working anaerobically. So usually once we're over 80% of our max heart rate, you can pretty much assume that you're only burning carbohydrate and that you're working at an anaerobic level. So there's obviously much more areas this goes into. I just want to give you an overview of how we get the energy for us to do our activities.